didn't go all the way down.
Record.
Okay, so is it going then?
Mm-hmm. It's
Okay.
going.
All right, so what else we got?
Hey, everybody.
Stuff that we haven't dealt with is the ball toss, right?
Yep.
Okay, so with the ball toss, what are we doing with that motion in terms of speeding up and slowing down?
It was speeding up at the beginning and then it was slowing down to zero.
For which one? The toss this way or the toss this way?
That way.
Okay, so the toss horizontal.
Wait,
horizontal.
which one are we talking about?
The toss across the
When they
room.
threw it to Ruth,
Yeah, the one that was across the room.
Oh, it was.
The bottom.
because it was speeding up at the beginning and then it slowed down towards the end.
So, okay.
It
so
had
here's-
acceleration towards the end.
Yeah, it did have acceleration because the instant it left my hand, the only thing that was acting on it was gravity, right? So that meant it was, at the very least, it was speeding up on the way down. Now, this goes back to the thing we were talking about yesterday with that you have to have, that we're talking about motion. We're not talking about the force that puts it in motion or the force that stops it from moving. We're talking about right after the force lets go, and right before the force stops it. Because if I'm holding the ball still right now, okay, if I'm holding the ball still, it's not doing anything. But when I start swinging and I'm pushing, I'm not gonna throw that right.
I can do it. I can do it.
Okay. When I'm pushing it forward, the instant it leaves my hand, is it moving when it leaves my hand? My hand lets go?
Yes.
Because if my hand has got a speed and I'm holding onto the ball, then the ball has a speed. Okay, kind of like if you're in a car, the car's going, then you're going at speed as well. So as it leaves my hand, it has a speed. Okay? Yeah.
And that's also why if you were to get like I don't know, see a key, like your keys, right?
Uh-huh.
Or not your keys, because okay, like a ball, right?
Right.
You're in a car
Uh-huh.
and you're with the ball and you throw it up. The ball's not gonna go back because they're going the same speed as the car.
That's exactly it. That's the idea of relative motion. So, and by the same token, when it hit his hand, right?
I never thought about
Okay?
that.
Right before it hit his hand, was it still moving? The instant before it hit his hand,
Yeah.
okay? So for it to stop moving, the force had to come in. So we don't care about the force that made it move and the force that stopped it moving. We care about it the instant after it leaves my hand and the instant before it hits his hand. Okay? So during that time, it has velocities. Okay? I'm going to backtrack a little bit to the straight up and straight down thing because that'll make part of the ball toss easier to understand. So if I toss it up, I toss it down. How does that motion break down? What's happening? As I toss it up, what's the ball doing?
It's accelerating.
Speeding up?
It's accelerating negatively
Well, when
because it's going
Why are your hands
because gravity's
speeding up?
pushing down on you.
Okay, accelerating negatively or, okay, why are we saying that it's accelerating? Expand on that just a little bit. So if I throw it into the air at 10 and I catch it at the same height, how fast is it going when it hits my hand again?
Zero. Wait, what?
Right when it hits my hand, not talking about the force that causes it to stop. I throw it up, it leaves my hand going a velocity. We're going to say that velocity is 10. So if it leaves my hand going 10, it goes to 0 all the way at the top, right? And then it comes back down.
10.
If I catch it at the same height, it's 10 the opposite direction. So at the same height, 10 starts and 10 stops. All right, that's how the speed's going to be. Same thing happens, all right, ready? On that, okay? Because we just went across the distance, but in terms of up and down, did there have to be any distance between us? It basically went up and it went down, and if we caught it at the same height, however fast I tossed the ball, and if he had theoretically caught it at the same height, if my toss had been maybe like that, much better, then they're going to be the same speeds, because they toss up and they toss down.
But they just have different signs.
Different signs, up and down.
Okay.
Okay, that's basically what a vector is, guys. If you're paying attention to whether or not it's going up or down, if you're paying attention to whether or not it's going up or down, then that's a vector. So if it's not, it's just speed. So it's 10 up, 10 down. I think I said that incorrectly. It's a scalar if you don't have any direction on it. So what other should we toss in with that? Horizontal motion first. Okay. Sorry, Cortez. All right, there you go. Yeah. Okay, so when we do that, right? So we just talked about. At least they weren't all Michaels in this class. Okay. I have a class with like 3 Michaels, 2 Miguels, and I have a couple other Michaels and Miguels in all my other classes. So if I don't know, I'm just gonna start calling everybody Curtis. Yeah, okay, but how we just talked about that, me tossing it to Cortez, there's no difference in the up-down portion if I'm here, or anywhere, or if he's just doing it himself. The up-down portion is just literally up-down. And what happens to the speed? It slows down going up, speeds up going down. The instant it leaves my hand, what do we say was acting on it? Acceleration due to gravity. Now, the horizontal portion of the motion, yeah, I'm gonna toss. The horizontal portion of the motion, what's causing that to change?
I don't know.
Can you think about it? Because like, if nothing's touching it, the only thing acting is gravity, and gravity's up and down. So we could say that for the ball toss, okay, the ball toss, okay, you can just throw them off. The ball toss is slowing down on the way up, and the ball toss is speeding up on the way down, but on the way over, there's nothing to change its motion. So the horizontal portion, this is really weird, but it's kind of cool. The horizontal portion is constant. Think about that. The ball toss horizontal is constant. So the only thing that changes the motion in a ball toss or anything moving, any projectile thing, is gravity. So that means that the only speeding up or slowing down is this way. There is nothing to change this motion. All right? So that means that your horizontal motion is constant, but the vertical motion is changing. You see that? Any questions? And that makes the dart gun very much like it. Okay? Where should we put the dart gun?
Under constant as well.
Constant only if we're talking about the part speed that it leaves. Okay? So the dart gun, the horizontal portion of it is constant, but it ends up on the ground, right? So because it ends up on the ground, that vertical portion is changing. So
Wouldn't the dart gun also slow down?
no, because as it leaves, right, what's acting on it? Only gravity. And so only gravity is doing it, means it's pulling it down. And as it gets pulled down, it's going to get faster and faster and faster. Because the gravity that we're talking about is the acceleration due to gravity, which is speeding up.
So dart gun will be part of speed up?
Mm-hmm. Yeah. Dart gun. Well, if you're pointing it up, yes, it's going to slow down. If you're pointing it straight, like this, it's only going to go down. Does that make sense? Yeah. So if you've got a little bit of an angle up, it will do that slow down until it hits the peak, and then it'll speed back up. So, but the way I was trying to do it was a straight shot. So if I do the dart gun straight, then it speeds up vertically. It speeds up vertically. Okay? So this part speeds up. This part is constant. I'll put your pin down. This is actually looking pretty nicely. And I'm writing all over all that other stuff, aren't I? It makes it even hard to read or tell me when I do stuff like that. All right. Any other comments about these type of things? Yes, we got a lot of stuff out of tossing a ball around the room. And we're not even into numbers yet. All right. We're going to talk a lot more about this. This is just an introduction to thinking about the way things move. All right? So it's kind of a back of the brain so that when we talk about it, you have this mental image in your head of things that are going on. But I'm done, unless there's any other questions. Okay. Hit the off button. You hit stop recording, not pause.